So, just to go over memory versus memoryless systems. So, first of all, in the lectures, the teacher explained that a memoryless system is output. I'm just gonna write it like this. Its output is dependent on the present input, and this will make more sense in examples. And for memory, a system with memory, its output depends on the future or past values of its input. Future or past values of its input. And sometimes people call this static for memoryless, and some people call memory dynamic. So just to give you an example, so usually in our course, x of t is the input and y of t is usually the output. And for this example, let's say t just equals 0. So t equals 0. And let me just put this on a scale. So we have 0, 1, 2, 3. And then we have -1, -2, -3. And the 0 would be our present value. However, 1, 2, 3, or anything above 0 would be the future values, and anything before that will be our past values. So you kind of see where I'm going with, or how I'm going to be doing this. So let's say y of t equals x of t. So y of t equals x of t is our system. Let's say we take the 0 example, and we have y of 0 equals x of 0. So you can clearly see that the output is dependent on the present values of the input. Our present value is the value we plugged in, which was 0. And when we plugged in 0, we get 0 back from t. Okay, so let's say we had y of t is equal to x of t minus 2. So we get y of t is equal to x of minus 2. So we can clearly see that the output depends on the past values of the input. So this one relies on the present. This one relies on the past, or this system relies on the past. And we're going to have a third example. Let's say we have y of t is equal to x of t plus 3. So we plug in our present value 0. So y of 0 is equal to x of 0 plus 3, which is 3. So our output is dependent on the future values of the input for this example. So we can clearly see that this example has memory, or sorry, it's memoryless. This has, memoryless, and the next two have memory. So I wrote 5 examples here on the side, on the right, and let's just go over them real quick. So let's say we plug in our present value, which was 0, and we'll get x of 0 plus x of 1. So our output depends on the future values of the input. So this system has memory. Let's look at the second one. So let's say we plug in 0 for our present value. We'll get x squared bracket 0, and we'll get plus x of 0. So the output will depend on the present input. Since t is 0, it doesn't change, so it is memoryless. And for the next one, we plug in 0 for our present value, for our example from before, and we'll get 0 back. So this system is memoryless. The output depends on the present value of the input. And same for this example, we plug in 0, and we'll get 0 as our n. So the system has no memory, memoryless. And for our last example, we plug in 0. We'll get 0 here, but we'll get 0 minus 1, which is a past value of the output. So it has memory. And it's pretty easy to see with examples. And your present value doesn't always have to be 0. You can make your present value anything else. It could be 2, and then like you change all this 3, 4, 5, and then 0 and stuff. But it could be pretty much anything you want. But 0 is just a really easy one. And yeah, that's pretty much it.